Hey grade 11. This is a question that someone wanted some help with during our last class on Friday. So I'm going to try and go over it now. There's a few parts to it, but basically it's asking, how much energy do we need to boil 7 litres of water from 5 degrees Celsius to get it to 100 degrees. So how much energy do we need to raise that much mass of water by 95 degrees Celsius? And to do this, we need a formula that deals with specific heat capacity. Right, so Q is equal to MC delta T is the formula that we're using. Now, Q is the energy required. Sometimes, if this is cooling down, then it's the energy that's going to be given off. The specific heat capacity is a constant, and that's C in this formula. And for water specifically, the value is 4,200 joules per kilogram per Kelvin. And finally, delta T, change in temperature. Quite easy to find out. Now what we need to know first of all is, what does this formula really do? Well, this formula tells us how much energy we're going to need to increase the temperature of a certain mass of an object by however many degrees Celsius. So let's just do this first one real quick. How much energy am I going to need? Well, if I start plugging the numbers, I'm going to find that we've got 7 kilograms. So 1 kilogram of water is 1 litre. So we've got 7 kilograms of water. Remember, 4,200 is a constant. So that's never going to change for water. It's different for different materials. You might find that oil is somewhere around 950. And then our change in temperature is going from 5 degrees to 100 degrees Celsius. So I'm sure you can appreciate that's 95 degrees. If I do that, I get somewhere in the region of 2.6 times 2.8 times 10 to the 6 joules. So 2.8 million joules. The next thing that we need to work on is, well, how much propane do we need to get this energy out? So let's work on that next. It's telling us that 26 gigajoules is given in 1 cubic meter of propane. Now, when we actually consider the efficiency, we know that only 65% of that energy is getting through. So in real terms, what we've got is 26 times 0.65 joules of energy from every meter cubed. And if we do that, it's 16.9. So we're going to get 16.9 gigajoules for every cubic meter of propane we have. That's an awful lot of energy. And that's clearly more energy than we need, because we're talking megajoules, not gigajoules. Let's think about how many litres we might need. Now, there are 1,000 litres in 1 cubic meter. So we can just take this and knock it down by 3 orders of magnitude. So this is 16. And just make sure the pen's working. So 16.9 times 10 to the 9 joules per meter cubed, and then that's 1.69 times 10 to the 10. If we multiply that by 0.001, because there are 1,000 litres in a cubic meter, then we're going to get 1.69 times 10 to the 7 joules in 1 litre. Okay. Sorry, that should be 6.9 there. Alright, so we're really close to figuring how much propane that we need then. Well, we need a total of 2.8 times 10 to the 6 joules of energy, and 1 litre gives us 1.69 times 10 to the 7 joules. So we are going to need, if you put that into the calculator, you find that you need 0.164 litres of propane to give you enough energy to boil 7 litres of water by 95 degrees Celsius. And if we put that into millilitres, that's going to be 164 millilitres. Hopefully that helps you out with this process. This section here, this first section, is something we're going to definitely be revisiting. So if you're not 100% sure about it now, we'll be doing this again either later this year, maybe in a few weeks, but if we don't have time for that, then it's going to get moved to the next academic year, and we'll work on it then. Okay, ask me any questions in the regular chat, please. Thank you.